Ever find yourself kind of baffled by like how we're supposed to know anything for sure? You read a bunch of articles, maybe you even dive into some research papers and you think, oh, okay, I'm getting a grasp on this. But then how do you actually determine if that grasp is on something solid or if it's more like, quicksand?
Yeah, that's a great question to start with. I mean, it really gets at the heart of what we're digging into today, right?
Okay, good. So where are we digging today?
Well, we're going deep on the work of Karl Popper.
Karl Popper.
Yep, he's this philosopher, pretty influential guy, and he had some really radical ideas about how scientific knowledge actually progresses.
Radical, huh? All right, so what is it about this Popper guy that's so important for us to understand?
Well, we're going to focus on two of his big ideas. First, that any scientific truth is always provisional, always open to being revised and updated. And second, and this is a really key point, that science moves forward not by trying to prove our theories right, but by actively, rigorously trying to prove them wrong.
Prove them wrong. That sounds a little counterintuitive, doesn't it?
It definitely goes against how we usually think about things, right?
Yeah. So what are we using to guide us on this deep dive into Popperland?
Well, we've got some excerpts from his 1962 book, Conjectures and Refutations, and there's also this really helpful set of slides from 2025 that compares Popper's ideas to another big thinker, Thomas Kuhn.
Okay, so if I'm following you correctly, our mission today is to get a handle on Popper's take on scientific knowledge and how it stacks up against other viewpoints, especially this thing called induction.
Exactly. And this isn't just some abstract, heady philosophy stuff. By the end of this, you'll have a whole new way of looking at how you evaluate information, why some ideas stick around and others fade away, and how scientific understanding, even though it's always evolving, ultimately moves us forward.
All right, I'm intrigued. So let's start with this induction thing. What was Popper's beef with it?
All right, so induction basically says that we can go from observing specific things to making general rules. We see a bunch of green apples and we conclude, okay, all apples are green.
Right, classic pattern recognition like we do all the time.
Exactly. The problem Popper saw is that no matter how many green apples you see, you can never be absolutely sure there isn't a red one or a yellow one lurking out there somewhere. So you can have tons of confirming instances, but one single exception can topple your whole theory.
Huh. So no matter how much evidence you gather, there's always a chance you could be wrong.
Right. And for Popper, that just wasn't a strong enough foundation for scientific knowledge. He set a really high bar. Induction alone just wasn't going to cut it.
So if science isn't about building up general truths from these specific observations, then what did Popper see as the real engine driving scientific progress?
Okay, here's where it gets really interesting. Popper's big idea is the power of falsification. He said that instead of trying to confirm our theories, we should be actively looking for ways to disprove them.
So instead of searching for evidence that supports what we think, we should be trying to find evidence that proves us wrong.
Exactly. See, no matter how much evidence you have supporting a theory, you can't ever definitively prove it true. But a single piece of solid evidence that contradicts the theory, that can prove it false.
It still feels a little backwards, but I guess if a theory survives all these attempts to debunk it, that does make it more reliable.
Right, it's like stress testing an idea. The more it withstands these attempts to falsify it, the stronger it becomes. It's not about proving it true in some ultimate sense, but it means it's the best explanation we have at this point in time. Popper actually put it really well when he said, the way in which knowledge progresses is by unjustified anticipations, that controlled by criticism, by attempted refutations.
Okay, that makes sense. So if trying to disprove theories is so valuable, why was Popper so down on verification? Why isn't it helpful to find evidence that supports our theories?
Well, he used some really good examples to illustrate this. He talked about Marxism, Freudian psychoanalysis, and Adlerian psychology. What he saw was that the followers of these theories could always find what looked like confirmations of their ideas everywhere they looked. Like someone looking at the world through a Marxist lens, they'd see class struggle in just about every event. Same thing with the Freudians and Adlerians. They could explain just about any human behavior within their own framework.
So it sounds like they were just seeing what they wanted to see instead of genuinely testing their ideas.
Exactly. Popper even told this story about a conversation he had with Alfred Adler, one of the big names in psychology. Popper presented him with a case that didn't seem to fit Adler's theory, but Adler was able to explain it away using his ideas about inferiority feelings without even knowing much about the person.
That doesn't sound very scientific.
And Popper thought so too. He asked Adler how he could be so sure, and Adler basically said, because of my thousand-fold experience. Popper's response was great. He said something like, "And with this new case, I suppose, your experience has now become 1,001-fold?"
Ouch. So if a theory can explain literally anything, does it really explain anything at all?
Right. Popper was saying that these psychoanalytic theories, even if they had some interesting insights, were basically non-testable, irrefutable. No matter what evidence you threw at them, it could be twisted to fit the theory. He said it was like astrology, where people can always find apparent connections between predictions and events, but that doesn't make it science.
Okay, so for a theory to be truly scientific, it has to be vulnerable. It has to have the potential to be proven wrong.
Exactly. There has to be some conceivable observation that could contradict it.
This is really making me rethink some basic assumptions. I always thought science started with careful observation of the world. But you mentioned earlier that Popper had a different take on that too.
He did. He actually called it the myth of pure observation. He tells physics students, take pencil and paper, carefully observe, and write down what you have observed. And they'd say, well, what am I supposed to observe?
Good point. You can't just observe without some kind of direction, some idea of what you're looking for.
Right. There's no such thing as just pure objective observation. We always approach the world with some pre-existing ideas, some theories or questions, and those shape what we see and how we interpret it.
So if science doesn't start with observation and then build up to theories through induction, then what role does deductive reasoning play in Popper's view?
Okay, so while Popper didn't think theories came from pure observation, he thought deduction was super important. Once you have a theory, like a hypothesis, even just a hunch, you use deduction to figure out what should happen if that theory is true. What specific predictions does it make?
Oh, I see. So you come up with an idea and then you figure out, okay, if this is right, then we should see X happening.
Exactly. And then you go out and look for evidence that either supports or contradicts those predictions.
And if it contradicts, then you know your theory needs some work, or maybe you need to scrap it all together.
Right. And this brings us to another big idea from Popper. Tentative truths. He emphasized that even our best, most well-supported scientific theories are always provisional. We can never be absolutely certain that they're true. There's always the possibility of new evidence coming along and changing everything.
It sounds a little unsettling. If we can never be completely sure, what's the point of all this?
Well, the goal isn't to reach this absolute, unshakable certainty. Popper thought that was impossible in science. Instead, it's about getting closer and closer to the truth by identifying and getting rid of false ideas. He had this really great analogy of a mountain peak that's hidden in the clouds.
Okay, I'm listening.
So this peak represents objective truth. It's out there, regardless of whether we understand it or not. And we, as scientists, are trying to climb to the top of that peak. We may not always see the summit clearly, and we might even mistake a lower peak for the real one.
But the real peak, the objective truth, is still there.
Exactly. And even if we can't be totally sure we've reached it, we can usually tell when we're on the wrong track. If our theory has contradictions, if it doesn't fit with the evidence, that's a sign we haven't reached the summit yet.
So even though absolute certainty might be out of reach, we can still make real progress by figuring out what's definitely false and moving on from there.
Exactly.
This is a really different way of thinking about scientific progress. So earlier you mentioned we'd also be looking at Thomas Kuhn. How do his ideas compare to Popper's?
All right, this is where things get a little more complex. Popper was focused on how science should work, ideally. He was laying out this logical framework centered on falsification. But Kuhn was a historian and philosopher of science, and he looked at how science has actually progressed through history. He's famous for this idea of paradigm shifts, these big fundamental changes in how we understand things within a scientific field.
So it's like Popper's saying, here's the ideal way to do science, and Kuhn's saying, well, here's how it's actually played out.
Yeah, that's a good way to put it. Both Popper and Kuhn rejected this older idea called naive positivism. That was this belief that we can just directly observe reality and build up totally objective theories from those observations.
Kind of like building something brick by brick.
Exactly. Popper and Kuhn both recognize that scientific theories are always provisional, always open to change, and that the way we see the world is influenced by the theories we already have.
Okay, so they agree on some key points. So where do they really diverge?
One big difference is in how they see science relating to truth. For Popper, science is this ongoing process of getting closer to the truth by weeding out false theories. But for Kuhn, the idea of truth is a bit more relative. It's tied to the dominant paradigm, the framework of understanding that's accepted by most scientists at a given time.
So when there's a big paradigm shift, like when we went from thinking the Earth was the center of the universe to understanding that the sun is, it's not necessarily because the new paradigm is objectively truer. It's just that it's better at solving the problems that the old one couldn't handle.
Yeah, that's a key point in Kuhn's view. He even compared it to survival of the fittest among competing paradigms.
So for Popper, there's this objective truth out there, even if our understanding is always incomplete. But for Kuhn, what counts as a valid explanation can actually change as the dominant paradigm shifts.
Precisely. The slides we have actually give a really good example of this. The slow acceptance of germ theory in medicine. From Popper's perspective, the medical community should have rigorously tested the existing ideas about disease and readily adopted germ theory once there was enough evidence. But Kuhn would say that it wasn't just about the evidence. The resistance to germ theory was also because of the existing medical paradigm, the way doctors understood illness and treatment at the time. Accepting germ theory meant a complete overhaul of those fundamental beliefs.
It wasn't just a scientific shift, it was a cultural shift too.
Right, and for Kuhn, that kind of cultural shift is a key part of how scientific paradigms change. It's not always this smooth, logical progression. It can involve a lot of social and historical factors.
So Popper gives us this ideal model of how science should advance, focused on rigorous testing and the pursuit of objective truth. But Kuhn gives us a more grounded historical view of how it actually happens with these big revelations in thought.
Exactly. And this takes us back to Popper's realism. Even though he stressed that scientific theories are always tentative, he was also a strong believer in the idea that there is an objective reality out there.
A reality that exists whether we understand it or not.
Right. And for Popper, our theories are just our attempts to grasp that reality. When a theory is falsified, it's not just a failure of our ideas, it's a real interaction with the world, a sign that we need to adjust our understanding.
Okay, that makes sense.
This aligns with the whole idea of post-positivism, which acknowledges that even though we aim for objectivity in science, the way we see and understand things is always shaped by our existing theories.
So to sum up this deep dive into Popper, the core idea is that science isn't about trying to prove ourselves right. It's about actively trying to prove ourselves wrong. We're constantly making conjectures, testing them, and refining our understanding.
Exactly. And even though we might never reach absolute certainty, this process of trying to falsify our theories is what pushes us closer to a better understanding of the world.
This has been a really eye-opening conversation. And for you, the listener, Popper's framework gives you this really powerful tool for approaching new information and claims. Instead of asking, what evidence supports this? The real question, the Popperian question, is what evidence could potentially disprove this?
I like that. It really shifts the focus from confirmation to critical thinking.
Absolutely. So here's a final thought to leave you with. Think about a belief that you hold strongly, something you're pretty convinced is true. What kind of evidence, if someone presented it to you, would actually make you question that belief, maybe even make you change your mind? Popper's ideas really challenge us to examine not just what we believe, but how we form our beliefs in the first place.
That's a great point to end on. Gives us a lot to think about.
It really does.